Welcome everyone to the series Viewing Multidimensional Poverty from Many Angles. Coming to you today from Oxford, UK, New York City, and Washington, DC. I'm James Foster, Vice Dean of the Elliott School of International Affairs at GW, representing our Institute for International Economic Policy, or IIEP. I'm expecting Sabina Alkar to join us after a while from the Oxford Poverty and Human Development Initiative, or OPHI. And I also have seen Yanxin Zhang from the Human Development Report Office of the UNDP. All three of us are bringing you today's event entitled On Track or Not, Projecting the Global Multidimensional Poverty Index by Nicolai Suppa of Barcelona and Oxford, with commentary by Doug Gollin of Oxford University. Thanks for joining us today. In just a moment, I'll turn the podium over to my friend and colleague, Kyle Renner, who will do a quick run through the bios of the folks who are with us today. But in the meanwhile, I'd like to say a few words about IIEP, an institute at GW that supports faculty research, provides fellowships and training, and other opportunities for GW students, and presents a broad array of events each week. So, broad array, let me just go through this week's offering. Tomorrow, our Trade and Development Seminar will feature Christian Volpe Martinkus of the IDB discussing his paper, Linkages with Multinationals. On Wednesday, our Envisioning India series presents Taking on China, the Imperative and Agenda for India, with Ambassador Gautam Bambawali and Dr. Ganesh Natarajan. On Thursday, we have two great panels on trade, the first entitled Gender Inclusiveness in Trade, and the second, What Can We Hope For at MC12? Finally, on Friday, our China Conference series will present How is the rollout of digital RMB changing the financial system in China and abroad? You can find all the details about these and other events on the website iiep.gwu.edu. And if you have to miss an event, it's available on the YouTube channel IIEP GW. Now, without further ado, let me turn it over to Kyle for the introductions. Kyle.
Yes, hello, everyone. We're delighted that you joined us this morning, this afternoon, this evening, depending on where you are sitting in the world. We're very much looking forward to today's talk, which will be presented by Nicolai Barcelona, as well as a research associate with the Oxford. Nicolai holds his PhD in economics from TU in Germany, where he studied economics and sociology, and where subsequently he worked on a major research project entitled Multidimensional Measurement in Germany and the European Union, which was funded by the Research Foundation. We're very much looking forward to hearing from Nicolai today about the Global Multidimensional Poverty Index and where it stands. Our discussant today is Professor Doug Gollin, the Oxford University Department of International Development. Doug is development economics, familiar to many of you. He joined Oxford in 2012 after spending 16 years on the faculty at Williams College, and is currently research director for a program on structural transformation and economic growth. He also previously chaired the standing panel on impact assessment of the CGIAR. And so we think that he's a fantastic voice to hear from today in considering the current status of the Global Multidimensional Poverty Index and whether it's on track in the midst of a pandemic. So without further ado, Nicolai, the floor is yours.
Thank you very much for the kind introduction. Can you see the slides? It's there, no?
Yes, we can.
Okay, so thank you very much for the introduction and also for the opportunity to present this ongoing research in this seminar. This is joint work with Sabina, Alkaya, Ricardo, Nogales, Natalie Quinn, And yeah, this is research in progress. The title is On Track or Not, Projecting the Multidimensional Poverty Index. So when we are working on multidimensional poverty, we frequently encounter a situation like this. So after specifying the poverty measure, we may have harmonized the indicators over time. So we have, for example, as indicated here, two observations per year, for example, in terms of the headcount ratio. And now the question is, what's next? And there are many questions that can be, or we can formulate the question more specifically. So one, for example, is how high is poverty or the headcount ratio actually right now, or in 2020, before the pandemic, or maybe even in 2030? What is the headcount ratio then? What do we expect given the current evidence? A related question is whether the country is on track or not. So imagine the country has a poverty target, which is here indicated by the dashed line. Would the current trajectory or the current evidence suggest that we meet the target in whatever the target here is? And a subsequent question is how to set such targets in the first place. And actually, in this project here, in this paper, we are concerned to address, or we are prepared to address these questions. And what we actually explore is the different ways how to project the multidimensional poverty index, so how to arrive at a reasonable projection, for example, for 2020, for example, for 2030. And this is the main goal of this paper. So we are developing and exploring a modeling framework for multidimensional poverty to compute projections. And we do that with a global MPI. So how do we use this framework? So in the first place, we have a kind of methodological section where we explore the different alternatives, but then we also use the modeling framework to address different questions. And the first question is whether or not a country would be on track for a given poverty target. And we have here a hypothetical target, which is inspired by the SDG 1 to cut poverty by half until 2030. Subsequently, we also explore the feasibility of such a target. And this kind of question relates our research to papers that have been written in the context of the Millennium and also Sustainable Development Goals, where much of the critique was that the goals were actually not feasible, in particular for the poorest country or many of the countries in sub-Saharan Africa. And our evidence actually resonates with this literature. And so we are connecting here to this literature. And then the natural follow-up question is, so if this kind of target is not is resulting in or does not really work for many countries, how would we then arrive at alternative, on the one hand, feasible targets, but also maybe more ambitious targets in order to bring about policy change? And we're not the first paper addressing this question here. This has also been done to some extent in the literature. And one argument here is that at least the poverty target should become developed or derived country specifically, rather than a uniform target for all of the countries. So, but why do we include this here? Because the idea is that our modeling framework actually has something to say on how to set these targets, how to arrive at feasible and yet more ambitious targets. And we also cover some implications for data collection on an intuitive level at the moment. So why should other people care about this contribution? So in the first place, this framework that we developed is crucial for poverty reduction, because that is something Atkinson pointed out. Understanding changes, and that includes also trajectories, is important to understand how to reduce poverty effectively and efficiently. Previous research focused on the changes, but the change story is kind of incomplete because there are, for example, we know very little about periods of acceleration or slowdown in poverty reduction. And there is another reason, which is also emphasized in Atkinson's last book, but also in the World Bank, in his World Bank report, is namely that the notion of triangulation across different poverty measures. So the idea is we consider poverty broadly, meaning monetary as well as multidimensional measures. And then on the one hand, we have the global or international comparable measures, and we have the national measures. And the idea is to compare how changes and trajectories for these measures perform, to learn more about whether how poverty can be reduced best and where the limitations of measures are and so on. And our framework is immediately applicable to the national measures of multidimensional poverty as well. So it can be applied beyond our example that we use here for the global MPI, or that we provide for the global MPI. And then there is also some of our implications that we discuss, and that's the third reason why others should care about our contribution here, is we argue for a particular model, namely the logistic, and many of the implications that we have follow from the bounded nature of our outcome variables. And so in this sense, they extend to many of, or most of the other sustainable development indicators. As it happens in that literature, the logistic model is not used throughout. Even in many cases, it's the exponential model. And we would argue here that may have problematic implications. So how is this talk structured? So I will quickly provide some overview on our data situation, the global MPI, the data sets that we have, and the timing. Subsequently, I will briefly cover some of the alternative projection approaches which have been used in the literature or on development indicators. But I will be very, very brief and just explain why most of the applied methods don't really work in our setting. And then section 4 covers the technical underpinnings of the framework that we're developing. This covers also some evidence in terms of which we believe is supporting our modeling choices. And section 5 then covers the results, and there are 2 subsections. One is of the hypothetical on-track exercise, and 2 is to explore to which extent these poverty targets are feasible. And then we have a discussion afterwards. So let's move on to the data section. So we use in this paper, we use the global MPI. The global MPI contains 10 indicators, which are all informed by MDGs and SDGs. They're organized in 3 dimensions: health, education, and living standards. We apply an equal nested weighting scheme, meaning all dimensions are weighted equally, but also the indicators within dimensions are weighted equally. And then since this is in the dual cutoff counting approach framework, we also have a cross-dimensional poverty cutoff of 1/3. So a household is considered to be deprived if it experiences more than 1/3 of the maximum possible deprivations. This global MPI is estimated mostly with data from the DHS and the MIX, but also from PubFam and some national surveys. And for this particular paper, we use the changes over time data of the last year, which is available for 75 countries and comes with carefully over time harmonized indicators for each of those periods. And we have precisely 2 periods for each of the countries. So then how is the data situation? So here we see the survey dates, and on the y-axis we see the year of the second observation, and on the x-axis we see the year of the first observation. And this figure answers the question, or provides insight into when the microdata was actually collected. How recent is it, and which period does it actually cover? And there are a few interesting observations here. On the one hand, we see that for many countries, so approximately here, the first period of observation is 2010 or later. And for many countries, the second period of observation is 2013 or later. So which is approximately here, this chunk of countries. And we also see that for many of the countries, we actually have a difference of 3 to 6 years between those data sets. This is what applies to most of the countries, but we have some outliers too. Some countries, for example, India, they have a particular long period between the two data sets, and other data is pretty outdated, for example, of Bolivia or Mozambique. So in the first approach, we can see how the changes would look like, the data. So this is like essentially plotted as is, although strictly speaking, then I wouldn't be allowed to connect the points. But what we see here already is that, again, the data comes from very different years. It has a different duration, but it also comes with different levels and slopes. And the idea is to develop an approach that allows us to give some more structure to this kind of data. So what are the approaches that have been applied previously in the literature? So on the first, I would like to mention the World Bank's approach to extreme poverty. The key idea here is they are relying on covariates, which is in that particular case, the GDP per capita, for which more recent data is available. And that in combination with distributional assumption allows to come up with nowcasts for monetary poverty. The problem is in the multidimensional, poverty index, this does not really work out because it's already been documented that the link with growth, for example, which would be the most likely candidate for such a covariate, is relatively weak. So that approach does not really work. There are other approaches that have been used in the literature for other development indicators, like, for example, child mortality. And in case of child mortality, for instance, non-parametric methods have been used. Which is not really feasible for us because we only have 2 years of observation. But other approaches include for child malnutrition, which is also a regression-based approach, which is difficult to adopt. But in addition to that, they also rely on exponential path models, which we consider, in our case, to be inappropriate. There is also one paper that applies actually the constant relative change or the exponential model to multidimensional poverty. But we argue in this paper that the appropriate approach for doing so is a logistic modeling framework. The interesting thing is there is one literature in the development studies, namely when it comes to indicators around education, like school attendance, enrollment, where actually the logistic model is used quite a lot. And we believe partly this is true because there is actually evidence available where we see the entire trajectory from low values to high values, where it becomes apparent that the logistic model is appropriate. So how does our modeling framework actually look like? So I will be brief. So we start with a typical Alkaya-Foster framework. So we're an accounting approach, and I will skip the initial part here on how to arrive at the aggregate measures. Our focus is on the adjusted headcount ratio, or M0 or M, which is shown here. So it's the MPI, if you want. And we are in particular interested in the MPI and its 2 sub-indices, the headcount ratio H and the average deprivation among the poor, the intensity denoted here as A. And why are we, in which way are we interested in these quantities? Well, the idea is that we are trying to model trajectories for countries for each of those quantities. These are country specific, and trajectory means this quantity as a function of time. And for convenience, we introduce here the Y, which could be any of those 3 indices here. And we also consider, or then we denote the time derivative as the Y with a dot. Now, we have to distinguish what we usually do in our work is we estimate from our microdata, and we denote this as usual with a hat. So, and we have different periods, we have different years for the countries, and we have 2 periods, tau 1 and tau 2 for each country, but the year itself may differ. So this is why we have the T as tau notation. The years may differ across the countries, they do differ. And then we also introduce the projection to be distinguished from the pure estimate, which comes with this wedge or reverse hat, if you want. And that projected value is available for every country and every T. And what we do throughout this paper is we to ensure consistency, so that this relationship here, that the adjusted headcount ratio is the product of headcount ratio and intensity, holds true for all of our projections. We derive actually the trajectory of M directly from the trajectories of H and A. So this ensures consistency of the approach. Now, let us take a look at the different models that have been used in the literature. At this stage, we consider 3 models, later only 2. At the moment, we have the linear model, the exponential model, and the logistic model. And in the first column, you see actually the outcome itself, or the trajectory, which is a simple linear function here. which is the exponential function in the second case, and the logistic as the third. Now, maybe it is useful to depict or to show how these functions look like. We see first the linear, which is the bright bluish here in the center. We see, for example, that function or that trajectory would violate the upper bound of 1 and the lower bound of 0. The exponential model, which is the darker blue one here, we see it would respect the lower bound, so it cannot go below 0, but it does violate the upper bound. And it's only the logistic model that actually properly respects both bounds here. So another interesting observation from this table is that if we take a look at the second column, these are the absolute changes. So we can interpret them as absolute changes. And we see why is this important? Because later we will compare the absolute changes and the levels in order to learn something about which of the models is appropriate. And the linear model would imply a constant. So imagine we want to scatter the change against the level. And the linear model would imply a constant in terms of the level, y. The exponential model instead would imply a proportional relationship. And the logistic model would imply a quadratic relationship. If we move on to the third column, here we see the relative change. And we see here, for example, that the relative change is constant for the exponential model, which is why it is also sometimes called constant relative change model. And in the linear model, the absolute change is constant. There are other interesting observations here. What holds for all of the models is that the beta in each of the models essentially defines the full trajectory. So the beta functions in this sense in the same way. The question is, though, how can we interpret the beta? And one way to do that is we see here, we can interpret the beta linear as an absolute change in the linear model. The beta of the constant relative change can be interpreted as a relative change. But what about the beta of the logistic model? Well, we can also write this in a little bit different way, and we can solve it for beta, and then we see that that is a kind of different relative change. So it's relative to y times 1 minus y. And the idea is this can be interpreted, it's not relative to the level only, but it's like kind of normalized to 0.5, which is equally far away from upper and lower bound. So this is one way to interpret. We also see that for very small, if we take a look at the relative change for very small values here, this term would vanish, and the relative change actually converges against the beta for small values of y. We also see that in many cases for small values, the exponential model can actually be a reasonable approximation for the logistic model. So then let's look at some evidence. Here we see the evidence, some cross-country evidence. This is descriptive, and I won't go beyond that, but we have a bit more if you're interested. So here we are looking at the data for the headcount ratio, the intensity, and the adjusted headcount ratio. And we plot annualized absolute changes of the headcount ratio against its level. And we see here that, that a quadratic relationship seems reasonable. In particular, it doesn't look like a constant or like a proportional function here. For A, it's a bit more complicated to assess, but still it seems not completely unplausible. And for M, we again see that a quadratic relationship is supported. In the paper, we do a bit more rigorous analysis. We have multivariate models, and we compare them in terms of adjusted R-square, for instance, but also various information criteria. I won't go into this detail here, but the idea is that the principal relationship is supported by the data. We also have an assessment of the dynamic models if we assume all countries would follow the same parameter, but I will skip that here for reasons of time. So how does the model calibration work? So the idea is, it's actually quite, so here you see the trajectories for H, which is the logistic model, and we have the trajectory, which is a modified logistic model. It's this one, which ensures that the bound of A is respected. A, the average deprivation among the poor, cannot fall below 1/3. And luckily, this is relatively easy to solve because the logic transformation results is linear in the parameters. So that's quickly to solve. And then we calibrate these equations, so these models for each of the countries. So we obtain the beta and the alpha. We're particularly interested in the slope parameter beta. And then once we have that, we can obtain the full trajectory by plugging in the different values for t, or the year if you want. And here in the lower right, you see the illustration, how the full trajectories could look like. The darker blue one here is the intensity trajectory. The middle one is the headcount ratio, and the lowest one is the adjusted headcount ratio. Now the question is, this is the theoretical consideration. How does that look how does the empirical side of that work looks like? Here you get a first sense of the distribution of our calibrated model parameters. And we see here, for example, in the bottom row for the entire world, we see the different betas. And we see here, this is the median is approximately 0.1. We also see that the interquartile range is approximately this median 0.1 plus minus 0.03. So half of the countries have a beta between 0.07 and 0.13. We see, if we look into the other rows, that there is variation across the world regions, which is not surprising. On the other hand, we also have to keep in mind that some of those regions have relatively few countries. South Asia, for instance, only comprises 4 countries, I believe. Now, this is the beta, but we still don't know. So the beta describes the full trajectory. The question, what we don't know at the moment is where on that trajectory a country would be. And there is a nice way to show that by kind of combining this information. This is what you see here in this figure. So the idea is in order to combine where the countries are in their particular trajectory, we rescale time in such a way that the implied inflection point for each of the countries is identical. And then we see that the logistic shape emerges. We do this same application also for the linear and for the constant relative change model, and it turns out to be, it looks less convincing. So it's a harder to rationalize pattern. So this is like one additional argument in support of the logistic. But then we also see in this figure, what is the implication of the different betas? So we see how, and here you see the different percentiles, if you want. The greenish one here is approximately the median. And then we see for higher performers, for example, here the upper quartile performance, so the 75 percentile, then the slope is getting steeper. And then we also have, for some countries with lower performance, for example, the 5 percentile is the reddish line, the slope becomes flatter. An interesting observation here is that I mentioned that, we saw that, remember this table that we saw, that the logistic model also implies particular profiles for absolute changes and relative changes. And we can look at that too. For instance, in the upper right, you see now how the absolute change would look like in this time rescaled figure. And what we see here is, as I emphasized previously, a quadratic relationship. So all these trajectories account for the period of acceleration and slowdown. And these figures, I think, are useful to make one point, namely that the pure or the exclusive use of absolute changes can be misleading. Because countries, for example, here say about what 0.02 or a bit more, 0.025 or so, these countries here, they may appear to be very similar in absolute changes, but in fact, they are on completely different trajectories or position of their trajectories. They could be easily on the slowdown side of this profile, or they could also easily be on an entirely different trajectory. So, and here you see the version for the relative changes. And again, we see several interesting features. On the one hand, we see, for example, in terms of the shape, how the trajectory here of the median, which is the bluish, well, it's not really blue, it's more green. The green one is converging against the actual beta, which is approximately 0.1. And we also see that then it's approximating the relative change model. And again, it can be deceptive to compare directly relative changes without any further information, because in many cases, this may, for example, in this year, around say 7.5% percentage reductions, they are very similar, and they can be easily entirely different trajectories. Could be a median performer, could be a top performer. And this is not this cannot be easily distinguished without further information. So then let's move on to the results section. So the hypothetical exercise that we are considering is as follows. It's inspired by the SDG 1.2, which is cutting poverty by half according to national measures, multidimensional poverty by half national measures. We use here the global MPI instead. We use also as a reference value 2015. We have in principle both outcomes, the headcount ratio and the adjusted headcount ratio, but we focus only on the age for simplicity. Our preferred model here is the logistic, but we also report some of the results for the exponential model. We don't consider the linear to be a serious option in this context. Something I won't provide further detail is how we derive standard errors for this, but it's certainly important, as we will see. The principal idea is what we know from our data is that we have sampling error, and we incorporate this sampling error into our error margins for the entire projections. And that we do using simulation techniques. So how do the results here look like? So here we see all countries that we have. They're sorted by countries being off track on the left and on track on the right. So how do we read the figure? The reddish arrow here shows the reduction in the headcount ratio according to the logistic model. The gray bars around that indicate the 95% confidence interval. And then we have also the black bars here, which indicate the target, cutting poverty by half by 2030. And we see here that obviously the countries on the right do not on the left, do not reach the target, whereas those on the right do. I won't discuss the country results here in detail. This is just to give you a first impression of how the results look like. I would like to discuss the result instead in context of this table. This is a kind of results summary table. And the really interesting, or what is sufficient for us, is to focus on the total line here, which is across all world regions. Occasionally, we will look into the world regions to get a deeper understanding. Now, first, we see the proportion met according to the logistic model, which is column 2, is 68% of the countries would meet the target according to the logistic model. Now, one thing is this does not incorporate standard errors. If we incorporate standard errors, we can test whether they would be significantly below. This is shown in column 6. We see the share of countries significantly below the target. The share drops to 48%. So one conclusion is that standard errors matter in this context. Then the other aspect we're interested in, how does the logistic model compare with an exponential model? And in this context, we see that the proportion met for the constant relative change model drops to 57%. Now the question is, and there we can look into the world regions, where does this disagreement come from? And we see mostly it comes from the countries in sub-Saharan Africa. There the share drops particularly strong. Why is that? What is the intuition for that? Well, sub-Saharan Africa is home to the poorest countries. And in particular for the poor countries, so with those with a high value of the headcount ratio, the exponential model is a particular poor approximation of the logistics. So in particular for high poverty countries, both models start to tend to disagree. And this is one observation here. And we can also compare those models more directly when we look at the column 8. Here we test whether the projection in 2030 is significant, or whether we can reject equality of the two trajectories. And we see seemingly only 17% the models disagree. But once we look into the world regions, this is mostly the case in sub-Saharan Africa, which is not surprising. But the conclusion here is the underlying model makes a difference for the projection in question. It can make a difference. It depends whether or not it's a good approximation, which in turn depends on the level of the poverty level of the country. So in one exercise, we are interested now to which extent are these results really feasible? Did the countries actually have a chance to meet them according to this in the setting? And you can, so what we're doing next is a counterfactual exercise. And you see here, as an example, the trajectory for Ethiopia. According to the logistic model, what we calibrated, it's the reddish line. So we would end up here by 2030. Now the question is, how would Ethiopia perform if it would boost or reduce its performance as understood or as measured by the betas? And we see, for example, if we Ethiopia is quite close to be a median performer. If we instead would assume it performs like a lower quartile country, then it would end up with a green projection. If it became instead an upper quartile, also almost a poverty reduction champion, it would end up here. But then we see even that is not sufficient for meeting the targets, according to our uniform goal specification. And so there are different lessons that can be learned from this exercise. On the one hand, we can see to which extent policy makers can make a difference, so changing the actual trajectory, or so it's not the predetermined result. And additionally, we can assess the feasibility. So because we know, for example, what kind of poverty reduction performance has been observed in other countries. So here you see one way of doing this counterfactual exercise. We consider those countries who did not meet the target and assume they were able to deliver median performance, which is empirically frequently observed. So there is a case for that performance. And we see for quite a few countries here that countries would indeed meet the target in that case. But many other countries, in particular Chad, Niger, or even Ethiopia, Burkina Faso, they all still would not meet the target. Conversely, many of the countries who meet the target, if they were reduced to lower quartile performance, they would fail to meet the target. Not all of them, but some. So we see the kind of trajectory can make a difference, the performance can make a difference with respect to achieving the target or not. But we also see that for many countries, it would still not be sufficient to, this performance would not be sufficient to reach the target. So another way to look whether or not this is a feasible target is actually to compare actual and required performance. And this is done in this figure. Let me walk you through some of the key insights here. It contains quite a bit of information. On the right-hand side, we see the year difference for the countries, when they would meet the targets. So the countries here on the right-hand have a negative value, which is here the year difference, the gray bar, which tells us they would meet the target already in 2020, which is so 10 years earlier than the target period. And this is already an interesting observation because we have about 20 countries that would meet the target already 10 years earlier, which is quite a lot if you consider that the entire period is 15 years. So after 5 years, they meet already the target. So this does not really trigger any change in policy if the target is met in this way. And then on the other side of the spectrum, where we have the countries which have by tendency the lower performance, we see that they need not only 2 or 3 years more, that in many cases for a 10 or a dozen or so countries, they need 10 more years, or in the case of Chad, even 140 years, which is the most extreme case. But for many countries, we see something between 10 and 20 additional years they would need. Now, one thing is we can also, so this is the years they would need. We can also look into the actual betas needed, which are the green dot. The actual actually observed betas are the green dot, and the bluish ones are the needed betas. The interesting thing is that for several countries here on the left, we see the green dots quite low. And that essentially means they have a relatively poor performance. And if we compare that with the needed beta, which are the blue dots here, we see many of the needed betas are around here. So for example, for Cameroon, for Senegal, for Nigeria, this performance here has been seen in other countries before. It's not like a top performer. It's like still lower quartile performer. So this is something one could consider to be feasible. Whereas for Chad, Niger, and Burkina Faso, they would need betas that have never been observed. Sorry, I forgot to mention the dashed line is again the interquartile range, and the middle one is the median. So for these countries, it's like really over demanding. So then let me move on to some of the discussion. We conclude that the one-size-fits-all approach is rarely appropriate. It's a problem. We have some countries which have no chance to meet the target. This can be discouraging and even cloud successes. So it comes with a cost. At the same time, for many other countries, it's an unassuming target, and it also doesn't trigger any policy change, what usually these development targets seek to do. So this does not really work out. Then the literature emphasized that initial conditions matter in target setting. This includes the levels. This has been frequently emphasized. Bill Easterly's article is probably the most famous one in this context, but also inequality has been sometimes been mentioned where countries differ, and also recent trends. And this is something we want to emphasize and underline here. It has been mentioned occasionally, but we don't think it's fully appreciated. And the third key point is also, which is actually acknowledged in the SDG themselves, that political priorities might vary with the countries too, and also the resources available to them. So from our point of view, it's not an academic exercise to derive the right target, but we have to provide the tools in order to inform the target choice. So the goal here cannot be to derive definite targets, but rather to explain how to proceed. And how can we do that? So the idea is we begin with getting the business as usual projection right. So what does that mean? So first we account accurately for the level where the country is standing, but also for the recent trends. And on the next slide, I want to make the point again that these things are different. Level alone is not enough. So, but in order to get the business as usual projection right, we also have to use the correct model. And now let me recall quickly from the on-track exercise. For 17% of the countries and for 26 in sub-Saharan Africa, the model results in significantly different projections. So this makes a difference beyond sampling error. So then we have the business as usual trajectory. But how can we now proceed for arriving at more ambitious targets? And here is where the betas of the logistic model come into play. The idea is that the betas describe the full trajectory, and they are informative, and they allow actually informative performance assessments across all the different countries, including subnational regions, for example. So we can easily compare the trajectories of countries which are otherwise quite different for different levels of poverty, for instance, which does of course not mean that the policy measures should be the same, but that's a different debate. And so this alternative beta then could be used to inform or to derive the projection. And an important aspect to distinguish is that the derivation of the projections is something different from formulating the targets, because whenever we arrive at a particular projection, we can consider what is best for communication purposes. We can reformulate that target actually in terms of absolute changes, for instance, or relative changes, or even as a target level. So let me quickly, maybe it's beating a dead horse, maybe not, but let me again explain that the levels and the coefficients and the betas are different. And we see, for example, here in this figure, that for every level of poverty that we observe here over the entire value range, we see actually very different performance. And very different does not mean, well, a little bit more, a little bit less. Consider the example of Togo or Cameroon here, which is something about 0.5 headcount ratio. This is a completely different situation than, for example, in Rwanda, who have a very high beta. They are actually above upper quartile performer. They are among the top performers, given that headcount ratio. So levels, so given the same level almost, the trajectory can be very different, and that has to be taken into account. We see again here the dashed line is again the interquartile range and the median respectively. So then one implication for better data. Why is this important in this context here? On the one hand, if policymakers want to know whether they are on track or not, it's really important to have, for example, recent data. That's one observation from our on-track exercise. But it also obviously matters for target setting. If you take the case of Mozambique, the most recent data is already more than 10 years old. There is a significant or a substantial uncertainty attached to the range. And this is illustrated, I think it was the example of Mozambique, what we observed in a poor data situation, that we have in the projection for 2030 of the headcount ratio, a confidence interval of 20 percentage points. So how confident would you be to pick your target in that situation? And there are different ways. At the moment, we do this intuitively, but it could be done empirically or maybe analytically. What are the factors to improve the precision of projections? And one is obviously more frequent and both more frequent and more recent survey data. Larger sampling sizes may improve the situation in some instances, but also what matters is the longer total period that is covered by the data. So then let me quickly come to some concluding remarks. Actually, I would like only make two remarks. One is that we believe that the betas offer a useful quantity to look at, complementing absolute and relative changes, what has been done previously. And this can be useful to inform target setting. And then I would like to anticipate one very obvious comment briefly, which is, how about projections and the pandemic? Well, I have to say a good one, and hard to say. It may affect, so we cannot take our results obviously at face values anymore, at face value. But the idea is that we actually try to say something about that in a standalone contribution, which has recently been published. We don't dare to say how the trajectories changed due to COVID. This is only something we can learn with new data. But the idea is to which extent there is a level shift in the pandemic from an ex-ante point of view. But that's something, kind of a cautionary remark or a disclaimer regarding the empirical value of these specific projections. And then I'm done, and I'm very happy and looking forward to Doug's discussion and to all of everybody's comments, questions, suggestions. Thanks for listening.
Great. So thank you so much. Really appreciate it, Nicolai. I'm going to turn it right over to Doug in just 2 seconds to remind you that you people in the audience, please formulate your questions and put them into the Q&A function in Zoom. Doug, carry on.
Right, will do. Let me see if I can share some slides with you now. Here we go. So I think the first thing I want to say is just to thank the organizers and to thank Nicolai for a really nice presentation of what's actually both a very interesting paper and a challenging paper. And so I want to compliment Nicolai and also Ricardo and Natalie and Sabina for what I think is a really important piece of work and one that deserves a lot of attention. So I have a few comments. I have to say I'm coming to this very much as a non-specialist in the area, as I think people will appreciate. I'm well out of my areas of expertise. So I've put together a few comments, some of them kind of narrow and focused on specific things, and then a little bit of stepping back to try to ask some bigger picture questions about this. So I think the first thing to say is that the paper considers very thoughtfully a number of different approaches to projecting out changes in the MPI. It goes without saying that projection is a tricky and a very delicate business. And I think what gets a lot of attention in the paper and also in the presentation, and impressively so, is the sensitivity to both data and observation and measurement, and then to choices that actually get made, but also choices that I'm going to talk a little bit about, but the question of whether our projections actually account for the things that might really matter. So in other words, anytime you're making projections, there's a question about how sensitive your results are to the things that you're actually focused on. So here to the country-specific programs aimed at reducing poverty, and then how sensitive they are to everything else that's changing in the background. I'll talk more about that. I also want to spend a bit of time right at the beginning talking about the sensitivity just to the math and the analytics of functional form assumptions, which Nicolai spent a bit of time on. The paper devotes quite a bit of time and attention to, but which I think is important here. The exercise is, again, kind of an impressive undertaking to take the existing data from MPI construction for different countries and to use both the cross-country experiences and some theoretical insights, I would say, to produce a methodology for estimating trends within country trends over time. A kind of key step in this, and I want to think about it just a little bit, is that you need to assume some functional forms that you're going to apply to each of the three, so the intensity measure, the head count measure, and then the overall measure, the M. For this, they end up concluding that it makes good sense to use a logistic model for the head count measure and a modified logistic model for the intensity. And then once they've chosen functional forms and a model, the exercise is to estimate the parameters under a number of different specifications and to apply them both to the relatively short-term observed data and also to the relatively short-term projections out to 2030. So these aren't, and I say relatively short-term in the sense that unlike, for instance, climate modeling, we're not trying to project out 100 years. We're trying to project out in a relatively, it's not unreasonable to think that the trajectory from the past 10 years might tell us something about the trajectory over the next 5 to 10. It's less of a leap of faith than you might think in other contexts. So I didn't actually do the hard work of analyzing or reanalyzing any of the data, but when you look at the figures in the paper and in the slides, one of the striking features of the data that's absolutely consistent with the logistic model that they're estimating is that, you know, logistic models give you a pretty linear look for big intervals in the data. The real sensitivities in the logistic model are both at the very high ends and very low levels of poverty. And that works well if what you're looking at are countries that are moving along that big middle range. In a sense, fitting a logistic model to countries that you see moving from 20% to 10% measures on the head count seems like you're in a comfort zone that wouldn't be where the particular parameterization of the logistic model isn't going to be too problematic. As you get down to very low levels, I think if my reading of the underlying math here is right, it's going to matter a lot for the time to moving from low levels to extremely low levels. So again, I think it's telling and important and appropriate that the exercise focuses on, I always get my SDG subcomponents right, but for SDG 1.2, where you're looking at having poverty headcounts for countries where that level is not too high, it seems like an appropriate thing to do. You would worry a bit more about the goal, for instance, of eradicating extreme poverty altogether, where as you get down, the question of how long that last bit of eradication takes is going to be super sensitive to the parameterization of a logistic function. So there's clearly an overall question of functional form specification and parameterization. All I can say is that the authors have been very attentive to this. They report a bunch of results, assuming different specifications and different parameterizations, and I come away feeling, you know, there's nothing that you could possibly prove here, but feeling reassured that it's been taken seriously. But I flag it that raises, I think there's some implications for how far you could push this kind of analysis, what kinds of questions you could reasonably tackle using the betas that are estimated here, how confident you could be on projecting the betas out in, for instance, much further than the 10 years. I think you'd run into some concerns as you moved a little further out. So I flag that. I did have a kind of methodological question here, which again, I'm sure that the authors have thought about, but I didn't see it mentioned in the paper, which is, I'm wondering whether you would get the same results if for each of the many components of the MPI, the different subcomponents actually, you estimated logistic measures for each country with respect to those underlying components, and then reweighted to come up with an estimated change in the MPI. And my question is motivated by wondering whether in some cases, I could imagine that the MPI might be driven by relatively small changes in particular component measures that drop a country down below a threshold, but where beyond the threshold, or where you have a lot of activity in one or two components of the MPI, but where, as you try to project that out, there's no further contribution. And so I just flagged that as a question. It wasn't obvious to me that you would get the same results if you did the projections at the subcomponent level, and then kind of, I'm not sure exactly whether it's feasible, but then reaggregated or reweighted into a change in the MPI down the road. So I just kind of toss that out as a question to think about. Coming back to results for a second, I think one of the really nice and optimistic results here is that the paper finds certainly many countries are comfortably on track to meet their poverty reduction goals. That has to be good news for us in a substantive sense. And I think I really like the part of the exercise where the authors asked, could these countries set more ambitious targets and still expect to meet them? I think that's a really lovely piece of analysis and a really useful thing to bring back to governments and to be able to say, you can do more, that you're on track, not just, don't be content with just meeting the minimum target that you had set for yourself. Given that you've been able to accomplish what you've accomplished already, presumably it shouldn't be that hard to do a bit more. And I think that's a really encouraging and encouraging finding and an interesting piece of policy relevant analysis. The slightly worrying finding, of course, is that there's a significant number of countries that don't seem to be on track to meet their targets. And it's worth, what the paper doesn't get into other than kind of a geographic clustering of those, is whether we could tease out something more about what those countries have in common, what we know about the countries where the trends in poverty reduction don't seem adequate. I suspect, again, just kind of eyeballing, that other than that there are other characteristics that you could extract that these countries would have in common. So I shouldn't spend too much more time here, but I wanted to touch briefly on the kind of big, I suppose, the epistemological question of what it means to project and what we're actually projecting here. And I think the question of how much what we're projecting here is the predictable part of variation or the predictable part of change. And the question that has to be out there is, how big is the predictable part relative to the likely total variation? So there's a lot of things going on in the world. And, in a sense, the key assumption that underlies this as any similar projection exercise, so it's not unique to this exercise, is that when we observe changes over time in poverty headcounts or poverty intensity between 2 points in time within a country, that the changes we're seeing, first of all, are meaningful. And so they've thought about that in the context of measurement in constructing confidence intervals and so on. So how do we know we're not just seeing noise? But then, in a sense, the underlying, it's not really an assumption, but the underlying premise of the analysis is that these country-specific changes are reflective either of a policy regime or a global shift, something that they're actually the result of something, of a driver that is likely to continue, all else being equal. In other words, that the world of the next 10 years looks like the world of the past 10 years to the extent that we can extrapolate these trends in time. And I think that's a challenging set of assumptions for us in 2021. We've got 15 years in which we've seen a global recession, we've seen a global pandemic. We have been reminded daily, certainly in the last couple of weeks, of the ways in which climate change is, and I don't need for this audience to go on, but simply to say I think there's a big question hanging over this exercise of what the magnitude of the effects that we don't control and can't model relative to the magnitude of the things we can predict. And again, I thought the COVID exercise, which Nicolai touched on very briefly in the presentation, but is again really thoughtfully done in the paper that I saw, and also in the additional paper, which I haven't read in detail. But I think it's a great reminder that we need to be very cautious in taking these projections very literally, and the authors don't need to be encouraged to do that. So having said that, and that to me, those kind of big factors it's hard to think of any of those big global uncertainties as being optimistic with respect to poverty trends. I don't think we're in a moment where we imagine that the big unexpected, the big unknown unknowns of the future, if you like, are going to lead to higher growth rates of well-being or faster reductions in poverty. They seem largely negative. But on the optimistic side, I think one of the things I love about the MPI as a measure here is that these different dimensions of poverty are specifically not sensitive to growth. And it always makes me a little uneasy when in the MPI literature, people talk about kind of elasticities with respect to growth, because I think one of the beauties of the measure is precisely that it's not growth dependent. If you could predict that changes in MPI with a change in the growth rate, you wouldn't need the MPI, arguably. And so I think one of the things that's really, that I get optimism from here is that these different components and subcomponents are themselves feasible. They imply feasible targets. They imply things that governments and aid agencies can change and can deliver. They are targets that can be pursued explicitly, even in an unfavorable overall economic or climate environment. And so I think that's really a reason to focus on the MPI and to remind ourselves that our ability to achieve meaningful improvements in living standards and well-being are not strictly linked to the global economy. I think there's a lot of encouraging news in here from a policy standpoint. Poverty reduction has been going pretty well in the first couple of decades of this century. I wasn't, again, kind of eyeballing the data. There's a fair few observations where we have both the first and second observation in the second half of, in the teens rather than in the first decade of the 2000s. So there's nothing obvious in the data that looks as though we're picking up a slowdown in poverty reduction. But yes, with all the shocks, with the kind of this very uncertain and sort of threatening horizon, I think lots of grounds for caution, but lots of reasons to encourage governments to keep up the good work and to accelerate where it's possible. So let me stop there again with congratulations to the author team for a really thoughtful, really careful piece of analysis. I would encourage people to look at the paper. It's really a kind of a model of its kind of analysis, and I think the authors deserve a lot of credit. So I'll stop there.
Thank you so much, Doug. And an equally careful and thoughtful presentation and discussion of this paper. I really enjoyed this added on discussion with many other questions that I think the authors should respond to. So let me go ahead and direct it back, if you would, to Nicolai for a quick response to the, as I see it, maybe 5 questions that you raised, or some of the main ones, the priorities to be determined by Nicolai.
Yeah, first of all, thank you very much. Much appreciated. Thoughtful discussion and comments. Let me quickly pick up some of those components, but I also would like to hear further that there are also some questions in the chat box. Let me pick up quickly. I mean, regarding the different components, I mean, for now, we did not explore to which extent projections would differ if we project directly the adjusted headcount ratio and compare that based on the components. So we started off because it became hardly manageable in order to kind of get the evidence right. So we had to adopt something that we find most convincing, but it's certainly something to explore whether there is difference or not. I mean, for components, I assume you mostly had in mind for now the headcount ratio and the intensity. But of course, in principle, we could think one step further in terms of the indicators. I think that this relates also to one of the questions potentially in the chat box, but we were thinking also about the indicators, but the challenge is that it cannot be immediately derived. I mean, imagine we had projections for the indicators. What we cannot immediately derive is without further assumptions, how the headcount ratio changes and how the intensity because of the censoring in the measure. So we may see what happens to the deprivation rates in the marginal distribution, but we don't know, for example, whether it's the poor or the non-poor who leave or enter a particular deprivation. So there is a kind of unknown where we could make an assumption, but we did not explore that in this paper. But the idea is, I think that's a useful step forward, but it requires additional analysis and additional thought. So this is, we did not perform or did go in this direction. Then, I mean, yeah, I mean, there are, when it comes to how much we can infer from these numbers, or also like to which extent that's in particular for low rates and for high values, how sensitive that is. I mean, maybe the larger point here is also that at the moment we only have 2 observations, and naturally we would like to see whether the functional form is, starting with the functional form, is even supported from within country evidence, for example. But also if we start calibrating, we would actually not rely only on 2 observations, but more. And if we had, well, a good amount of observations per country, we could actually also check to which extent projected and actually observed values would differ. That is not at all at the moment possible. So that would kind of, so I mean, it's true that now climate change and pandemic are things we cannot predict, but unpredictable things happen in the past. And the question could also be, to some extent, how far tend projections to be off. But at the moment, we don't have this information for lack of data, but let's say we're working on that, on the data side too, to improve that. Yeah, quickly on the, I mean, just a note on the, yeah, actually the COVID publication I showed in the end is actually, well, we separated out that section of the on-track paper because it grew too much. So it became a standalone paper, which was that one. Initially, we had them together in one, but it was too much. Yeah, and I mean, yeah, the sensitivity, yeah. So what else do I wanted to comment on? I mean, maybe I think we have 5 minutes left, so maybe there is also something I can pick up from the chat, or.
Of course, let's do that. So I'll run right to the chat, and you can talk about the big assumptions underlying what you're thinking, yeah, and so on afterwards. Yeah. But we see that, first of all, why don't we get Janssen to go ahead and just come on board and talk your question in. Janssen, are you still there, or should I speak for you?
Yeah, please, I'm here. I just have three very brief clarification questions for Nicolai. First, I think he already touched upon. I also asked for how the composition of multidimensional poverty can be analyzed here. From the presentation, I didn't read the paper. From the presentation, it looks to me the composition was treated irrelevant in the exercise, just for him to clarify. But we know the composition is very important. Second question is about assumptions made in these projections. Then in this year's report, for example, we do have a little bit more information for some countries. First, we have 80 countries instead of 75. Then for some countries, we have 3 data points. But I think even with 3, it's very difficult to make any sensible projections, especially when the readers may ask why so, right? How to link the projections to what's actually happening on the ground. Many factors come to play, as Nicholas mentioned already. Then for a country like Chad, which I happen to visit a couple of times, I do see the big changes taking place in the country, on the ground, to the middle class in the country. So other factors like commodity price movements had a big impact, even though it's difficult to link MPI, multidimensional poverty reduction, to GDP growth. But that additional revenues provided by commodities exports really provide the means for the country and for the people to improve their standard of living and other development indicators. Then third is about Sierra Leone. We know it's a very interesting case because from the surveys, we know this is the country which experienced the fastest multidimensional poverty reduction. So I'm just curious, according to your projection, how soon the country will achieve the target. Then any ideas why the country registered such a quick reduction in multidimensional poverty during the Ebola epidemic. Then going forward, if without this epidemic, whether we can actually assume even faster poverty reduction. So these are the three brief questions from me. Thank you.
Great, go ahead.
Thank you very much for those questions. All good ones. On the composition, it's true that, well, I would say we don't take an explicit account of different profiles explicitly. Implicitly, something is incorporated through the combination that the same headcount ratio may come with different intensity. So in this sense, we account for that because the intensity is kind of separately projected, but it's not on the indicator level. It's on the level of average deprivation among the poor. So in this, I don't know on top of my head, but we could look for examples, maybe if where countries with similar headcount ratios result in different trajectories because of the intensity being different. Maybe that would be a useful example, but I don't know at top of my head which country that would be, but we can look into that. Regarding the role of other factors, yeah, like price impact, for example, in Chad. At the moment, it doesn't take any direct account of that. We simply take the data as given and we essentially ignore any other information. Now, is there a way to integrate that? One way would be that we have what has been done for other development indicators, that there are some regression-based models for which we have more information on other covariates. But even for growth, we know already the link is weak, but it could, and we had lacked the data in terms of the MPI at the moment to perform such an exercise. But it could be, from a methodological point of view, that could be one way. Another way could be if one knows a little bit about the link of, for example, one particular striking or important effect in one of the countries, say how the oil price or a particular price is related to some of the indicators, then one could work, for instance, with simulation techniques and assumption, kind of in the fashion as we did in the COVID paper. So we don't know exactly what the impact is, but the idea is you could try to incorporate that. This comes with lots of cautionary statements, of course, but how do you say, with disclaimers probably, but that could be one way to address that. And also in this paper, it's like mostly because of focus and lack in data, we did not explicitly explore why countries perform poor or bad. I think one reason for that is also, what we cannot do at the moment is to look actually into subnational variation. Because there we could see, in principle, if we did not do that at this stage, but we could see which regions we could calibrate on the subnational region level. We could see how our regions performing. We did not do that for different reasons at the moment, but it's on the agenda, so to say. And I think, that's the kind of a different direction, but it's also like a worth one to explore, is really to understand where the differences come from. It could be for subnational variation. I'm thinking of landlockedness, or I don't know. You could think of many aspects, or climate, to which extent there are interesting differences, but also more socioeconomic factors. But that's, I would say, on the agenda. So Yeah, so I think that will be my quick response here. I also saw, or maybe one question on, it was from the chat on whether we use the same betas. I'm not sure whether I got that right, but we actually do that as a kind of so the most of the analysis is not building on the same beta, but we have this analysis for assessing the functional form again. So there we assume we kind of have a regression model, if you want, the kind of fixed effects, similar type of thing, where we have a single beta for all of the countries and compare the functional forms again in terms of adjusted R-squared information criteria and so on. But we don't go beyond this at this stage. But yeah, this is what we did in that direction. I'm not sure. There is much more. I hope we can keep track of that somehow, or is it recorded somewhere?
We will indeed, Nicolai. In particular, the person who's chatting is a forecasting expert by the name of Constantine Bergi, who is in Dublin right now, I believe Trinity. And he said when he left that he'd be happy to talk with you and the authors about various aspects of forecasting. So we'll just leave it at that, however, for the current purposes, since we're really now over the time. I just want to thank everyone for being here. Doug, thank you very much. Yanchin, everyone. For those of you who want to stick around for a short bit, we'll be signing on to another location for a short thing. Take care and goodbye from Washington, D.C., New York, and Oxford. Bye-bye.